Welcome back, guys! In this lesson, we are finally going to add our game manager along with the UI manager. So, let's disable the game panel and enable the menu. Okay, first things first. In the menu, we are just going to add a button to play the game. So let's call it play button. Okay, let's anchor it to the bottom and move it down by a tiny bit somewhere around here so that it is kind of close to the thumb of our player. We can increase the width of our button and the height to something like this, I guess. What we can do is also select another sprite, maybe this one, and change the color to something greenish. For the text right here, we're going to switch that to Helvetica and write play in white and increase the font size. By the way, you can also auto size your text. So I think we're good. So yeah, we've got a nice play button. We can also increase the pixels per unit multiplier right here to diminish the roundness of our edge or corner. So I think that one thing we can add is an outline or a shadow to our button. So maybe let's move it down a tiny bit, and yeah, seems correct. So 0 for the X value and minus 20 pixels for the Y value. We've got our play button. We can duplicate this boy, drop it in the level complete and in the game over. Just for reference, in our level complete, it's actually going to be the next button. So to jump to the next level, we can switch the color to blue to differentiate it from the play button and write next. Okay. Now, in the game over screen, it's going to be the retry button. Okay, let's switch the color to a reddish color and write retry. Perfect. So we now have our three buttons, play, next, and retry. Let's see how we can use these buttons. So the first thing I want to do before creating the game manager is create an enum to track our game state. So let's open our scripts folder. Do we have one for the enums? Nope. So let's create our enum right here, eGameState. Let's open it. There you go. Switch that to an enum, remove the monobehavior inheritance, and create our values. So the first one is going to be menu with a value of 0. Then we have game with a value of 1, level complete, complete with a value of 2, and finally game over with a value of 3. Perfect. Now we can create our game manager. So let's open our managers folder, create a new monobehavior scripts, game manager. There you go. Let's right click on our manager's game object and create the game manager game object. Use this script and open it. Boom. Awesome. So the first thing we need here, because we've created the enum, is a game state value to track the current game state. So private eGameState game state. Perfect. Next, this game manager is going to be kind of different from the other scripts because it's going to be a singleton. A singleton makes sure that you only have one instance of that class in your game or in your current scene. So let me show you how singletons work. This is another game design pattern that is really commonly used. So singleton pattern, observer pattern are some of the most common patterns. So public static game manager instance. Okay. Then in the awake method, oh, come on, awake. Here's what we want to do. If the instance equals null, if we don't have any game manager instance right now, then instance should be this instance of the game manager. Otherwise, we're just going to destroy this game object because we already have a game manager running somewhere in our scene. So we don't need two. We only want one of them. Got it? And if you have a look at my Code Ninja course, I've made a really nice snippet that allows me to write this really quickly. So insta, boom, double tab, and everything gets written automatically. Perfect. In our start method, we want to start with the menu, right? So we can do something like game state equals game state dot menu. but no one will know that we've switched to the menu. So in here, we've got two possibilities. We could either use an action like we've done previously. I think it was in our, in many scripts actually. Yeah, we've got one in the level manager, right here. We've got one in the item spots manager. So we can definitely create one with the game state or the e-game state as an argument, so that anyone that wants to do something whenever we switch from a game state to another can execute some logic. But I want to show you another way of doing things here by using interfaces. Interfaces are kind of scripts that are contracts between scripts. Okay, so let me explain. Let's create our first interface. In our scripts folder, we're going to right click, create a new monobehavior script and call it iGameState listener. Listener, not listener. Let's open it. Boom. And instead of being a class, it's going to be an interface. So we can already remove the monobehavior inheritance and our two methods. Boom. So an interface, as I've told you, is a contract between scripts. If any of these scripts, let's say the goal manager, let's select one of these. I'm actually going to select level manager because the level manager should spawn the level as soon as we switch to the game state. So it's actually a good example to select. So level manager, there you go. In here, you can see that it does implements or inherits from the monobehavior class, but we want it to implement. So we are going to add a comma, iGameStateListener. So for now, we're not going to have any error because our iGameStateListener is empty. What I can do is just grab it and drop it somewhere around here. Perfect. So that we can see the changes. Let's imagine that we want any script that implements our iGameStateListener to have a certain method called void, I don't know, game state changed callback. And we can pass in the e-game state. Okay, let's call it game state. Boom. If we save, even though this one is not public, we are getting an error here. Why? Because the level manager does not implement the interface member. He is currently not complying with the contract that he has signed. By implementing the interface, he has signed the contract. So he must implement the game state changed callback. So what we can do is press Alt-Enter and implement the interface. Now, if we jump back at the end of the script, we can see that the method has been implemented. Awesome. Okay, got it. But how is it useful? Well, it is useful because now the game manager can look for all of the scripts that have signed the contract and tell them to call this method immediately. Okay? So here's how you can do this. We are going to create a new public void set game state with an e-game state as an argument. Boom. So inside of here, we can simply first write this.gamestate equals game state. There you go. And after that, let's find all of these scripts that implement our interface. So we are going to start by writing enumerable, and of course we need the collections. Boom, there you go. Of type iGameStateListener. We need the generics. Boom. Normally it was there by default in the previous versions. I don't know why they removed them. Let's call them GameStateListeners. Okay. These are going to be equals to find objects by type, boom, of type monobehavior. So let's grab all of the current scripts. For the sort mode, so sort mode, we want to use none. And by the way, what we can do is just grab this one and drop it here again so that we have more space to code. Okay, so at this point, we are grabbing all of the monobehavior scripts. So basically all of the scripts attached to game objects in our scene. And we want all of these scripts of type, so of type, and I think we need to use the link library here, boom, of type iGameListener. So iGameStateListener, boom. Okay, and at this point, we are just grabbing all of the scripts that have or implement this interface, that have signed the contract. We could store them at the start of our game, but let's imagine that at runtime we spawn one of these that do implement them. we will not grab it because we would have our iGameState listeners stored. So you need to find a compromise here. When designing your game, you need to choose. Are you going to store them at start and maybe miss one of them if it gets created at runtime? Or can you just search for them every time you want to use them? You decide. Then for each dependency, so each one of these game state listeners, so iGameState listener dependency in game state listeners, what do we want to do? Well, we want to call dependency.gameState changed callback with our new game state. As simple as it gets. Okay? So now it makes sure that whenever we call this method, any script that implements this interface is going to call the gameState changed callback method. So for the level manager, for instance, we can definitely spawn the level here. So spawn level. Okay, so let's remove this line from the start method. We don't want to spawn the level, at start, but we want to spawn it whenever we switch to the game state, not whenever we switch to the menu or the game over or level complete. So if game state equals eGameState.game, we can spawn the level. Otherwise, let's not do anything. Let's now jump back to our game manager. And instead of setting the menu right here, we can just write set game state, eGameState.menu, right? And to go one step further and complete this lesson, we can create a new method, public void start game. And in here, set game state, eGameState.game. This method is going to be linked to our play button so that we can see if we can spawn the level or not, if the level manager has called the onGameState changed method, or callback, So let's select our play button. Let's add a callback, game manager, start game. And we can already imagine doing the same thing for the next button and retry button. So let's hit play. All right, the level has not been spawned currently. We can also check the level manager. He has no child. But if we hit the play button, boom, the level has been created. Awesome. And we can't spot the goal cards because the game window is not active yet. So in the next one, let's add the UI manager to go one step further. See you there.